let me welcome Dr. Martin Snethlage, who is our Senior Technical Product Manager. He's over 13 years already with PTV, and he will present to you the auto-calibration of demand models. Martin, please.
Thank you. Yeah, my talk is, as he said, about demand models, about the calibration of demand models, and about a tool which has been added to Visum, which automatically calibrates a demand model. So since it is about demand models, we start with a theory about demand models, but not that much, only that a demand model can be seen as a machine which produces trip matrices. For example, as in this case, one matrix per mode. And then when we compare the output of the model with the observed reality, for example, in terms of model split, then we see typically that there is a certain difference between them. So the model does not completely reflect that what we have observed in reality. So what happens then? Typically, if there are some differences, we analyze, or the modeler analyzes the model, analyzes the reasons for the difference. Maybe there are some person groups not appropriate set up. So for example, we need another segmentation of the person groups. We have observed some different behavior in different areas and so on. So the modeler analyzes the situation, and then he possibly extends the model accordingly, and he repairs here and there, and at the end he checks again the model results compared to the reality, and again there will be a certain delta between model and reality, hopefully less than before, but our experience is that there always remains some certain differences, and which cannot be solved. That means we try to model it, but we don't see the effect what we need or what has been observed before. And what should we do then? So now I go to the typical approach, what a modeler does then if the model is slightly different to the reality. And to explain that, I first go a little bit deeper into the detail of the mode choice models, not that deep, but a bit. So just imagine a certain relation as seen on the right side. Then for this relation, every mode gets a certain impedance. So for example, for the mode walk, we would take the walk time. For the mode public transport and car, we would possibly take the travel time and plus some costs, ticket costs or gasoline costs and so on. And then we put all these impedances of the different modes into our mode choice model, so somehow into our machine. And the outcome is then the mode shares. So the probability that a certain, in this situation, takes a certain mode. And this is done, of course, not only for one relation, but for the whole model, for example. And then we see that the reality is not absolutely the same as a model. That is what I explained before. And say we are at this point that we cannot explain it, so that we don't have the possibility to extend the model to result in these reality values. And we don't see any other option to change the behavior. So at this point, we would add some betas. That is, if you have been before yesterday at the talk from Mr. Wasmuth, he explained, or he talked a lot about this mode-specific constant, or however you want to call it. And this is quite complicated, actually, what the meaning of this beta is. But in this case, first of all, it is just the only possibility what leaves to us. We need to add there some correction to get the right output. So, okay. And what are we doing then? We try to find out which beta we need to take in order to get the model to reflect the reality. So we start, for example, with a public transport. We try such a trial and error approach. We try some numbers, some constants. So we add some constant impedance to public transport and change the model results with this. And we go up and down with the number, and finally we and we finally reach, for example, the reality value of 15%. Here seen the second row of the modes. 15% in the model, 15% in the reality. Okay, very good. And then we go to the next mode, say to bike. Bike is currently in the model 25%. We want to reach 17%, so we try some numbers for the bike impedance. We get, for example, one, and they are in accordance. 17% model, 17% reality, but unfortunately, again, the bus or the public transport has changed, because when we reduce bike share, then the other modes win some share. So again, we go back to public transport, change again this constant until we get somehow an accordant. We have now the same numbers for bike and for public transport, but they're still not okay with the other modes. And we go on and we change the constants for walk. What changes again? All the results we had before, and so on and so on. And you can imagine that this takes a lot of time. Always run the demand model, change the constants a bit, again run the demand model. And all this, not only once for the whole model, but just imagine we want to do it once for every person group. We want also to calibrate the average travel distance. When we did this, again, the mode choice or the mode split has changed, and we start again with mode choice and so on. So this is not only time consuming, it is also nerve-wracking, and actually it is a thing what could be automated. And that's the reason why we automated it. So we invented a tool which does all this, actually more or less the same what the typical modeler does manually, now automatically by the new tool. And that's what I present now, this new tool. So the tool consists of two add-ins. One can call them a preparation add-in and an execution add-in. The first point is, or the first slides are about the preparation add-in. So I change to Visum and try a live demonstration. Hopefully that works. Okay, where do you find this add-in? You go to, oh, this is German. That's not good. Wait a moment, I change it to English. And so you start with scripts. Then there is Visum add-in. And there is the last entry is demand. And from that, the last is the demand calibration preparation add-in. So we start it. There it is. And then I apply it now. So that means I enter a code for this calibration part. I call that MS for model split. It's also my initials. Okay, and then I choose one of the two procedures here. So in the procedure sequence, you see two procedures of a typical 4-step model, the trip distribution and the mode choice procedure. And since I want to calibrate the model split, I choose the mode choice. And the calibration object is model split. That's what I want to calibrate. The rest is not that important for now. I come later to these points. And then I click to prepare calibration. And then something happens, something in the background, and I won't go to each detail. There are a few things what mainly happen. One is that this preparation tool added here to procedures, to the procedure sequence. That is this demand calibration procedure. That is what I called before the execution add-in, and a go-to procedure. So it performs a loop. That's actually what I told before, that we do this beta change, or the mode-specific constant is adapted in an iterative process, and we run the mode choice model again and again. Okay, and what did change in addition here? We can open the mode choice procedure and go to the utilities. So you see here the utilities of for all modes, and when we open that, then you see this part, and this means that you add here to the impedance a mode-specific constant. It is called MS beta, and each mode has such a beta, such an attribute, and that is what I showed you before. Yeah, that's exactly this beta. What else happened? Yeah, and there is this list, this mode list, and what you see here is there's a target value, or it's a column with target values, and what you should do is to put in here the mode share target values, what you want to achieve. So don't know, for example, 19% bike, don't know. And the rest should be then 11.7. Good. Okay, so these are the target values. There are some other user-defined attributes. There's an attribute for the actual values, so that what the model currently reflects. And I add them here. And there is the beta. Okay. So far. And what happens now if I run the model? So I will start here in single steps. So first the trip distribution is very fast here. And then the first demand calibration run. Actually, there does not happen that much. Only a few things behind the scenes. I don't explain them anymore. It's not that important for the principle of the add-in. So then we run first time the mode choice model, go back, and now actually the first execution of the demand calibration happens. And that consists always of two steps. The first step is analyzing the current status of the model. That means defining the current mode split. And if you run it, then you see here actual, in the column actual, you see the current model split. So it is quite far away from that what we want to achieve. And you see, and that's a second step, what this add-in does, it calculates new betas. So these betas are not the perfect ones, but this is somehow that what the calibration tool thinks should be added to the mode choice utilities, and hopefully we get closer to the target values. So that means when I run now the mode choice again, then this run uses these betas here. Oh, yeah. Sorry, that is for me. Okay, and I run it. Okay, mode choice model has run. The values here, the actual values, do not automatically adapt. It is not a formula attribute or whatever. It is updated when I run again the demand calibration add-in. And now you see, hopefully you see that the actual values are nearer to the target values than they have been before. And again, I have a new beta, so a new better estimation of beta. And that goes again and again. So in this case, I had, I think, 6 iterations. And what you see now at the end, we have a certain set of betas. So the mode-specific constants are estimated, and the fit is quite good. So you see the differences between target and actual is quite small. And of course, you can run it again. For example, maybe start from here and run again the calculation, and the result is even better. So now it is ridiculous good, I would say in this case. So that's even not necessary. Okay. So that's about the principle of this add-in, how it works. It's not the end of my talk, but yeah, it is. I hope that you understand somehow how it works and that it works. I go back to the presentation, step over some slides which have been prepared only in the case that the live demonstration does not work. Okay. Good. That's the main thing. There are some additional features of this add-in or options, and I will go now. I will turn to these options and features. So the first is, of course, it is not only about model split calibration, but as I said before already, also the trip length calibration, or better said, and we calibrate the average trip length, the average journey length of the model. So it is not a trip length distribution calibration. We just calibrate the average trip length. How to do that? We just choose here at the calibration object, we choose average travel distance. Yeah, and that's it. And what happens then? It is quite similar, but it's not exactly the same as in the case for the model split calibration. We add we add again a beta, but now we add a term beta times distance matrix. So we do not add to every destination a certain beta, but we have only one beta, and this is then multiplied with the distance matrix. And what is the consequence? If you do that, if you add such a impedance, then actually every destination gets a certain penalty, because every destination has a certain distance to the origin. But the relative utility change is larger for longer trips and less for shorter trips. That means there's a relative utility advantage for shorter trips. So if you add such a term to the utility or to the impedance, then the trips will get shorter. So this is a principle, and then the question may arise why we use the DID, that is a direct distance metric. So in Visum terms, this means direct distance. And why we don't use the DIS, that is a travel distance. So the reason is that this calibration, this average trip length calibration, should not be affected by the concrete street course. And if we used the DIS, so the travel distance, then it would be affected, and this should be shown by the picture below. Just imagine such a local bypass. So say you have a current situation without the bypass, and then you add the bypass, but in both cases, the impedance from A to B should be absolutely the same. And this means actually what you would expect is also your demand model should result in the absolutely same result. But if you used the travel distance for the calibration part, then you would get different results because the travel distance has changed, and that would change the results, and that is not desired with this kind of calibration. So we choose a calibration which is not which does not change just because of different street course. Yeah, that's the trip length calibration. Another feature is, yeah, can we see that? It is about the additional calibration level. The picture there on the left side is not good. It is too early. It should come one click later. So it is possible to add a calibration layer. That means you do not calibrate only the whole model, but per whatever. For example, per demand stratum. You want to calibrate the model split per demand stratum or per person group. So for each person group, you have a different model split, and you can set it here. And then you can filter you can add a filter matrix or define a filter matrix, what means that the effect of the calibration is limited to a certain set of relations. So for example, as in this picture here, you want to calibrate only the traffic inside the city center, and then you would add there a filter matrix which filters all relations of the inner city, and the rest is not affected by this calibration. So this is possible. You can limit the calibration effect. And then there is a step size. So in this case, the default value is 0.5. The step size is somehow how far we go with our better estimation in the direction what the AddIn thinks is the best guess for the next run. So there's an internal algorithm, and he produces a new better estimate, and this step size says how far we go into this direction. So if it would be 1, then we would exactly take what the AddIn says, but it can happen if you go too fast to the desired better, that you get somehow alternating results. That means in one iteration you get say a very high share of cars, and then in the next iteration you get a very low share, and then again a high share. So if you don't want this alternating experience, then you would use a lower step size, and the price is the convergence is not that fast, but on the other side you come to some convergence. So this is a user-defined value, and it is possibly different in every model. And what is possible, of course, is that you combine several calibration procedures. That means, as seen on the right side, you can, for example, first calibrate the trip length, so the average trip length, for example, 5 times. You go 5 times back, and then you go to the model split calibration, run that once, and go back to the trip length calibration again and run that in such a double loop. Oh, that's all already. Yeah, that was it from my side.
Well, thanks a lot, Martin, for giving us some overview of this new add-on procedure, or two add-ins, as you said. I wonder, we used to have, or we still have, this tool Calibri. It's also an add-in in Visum.
Procedure,
it's
yeah.
a procedure. How does this relate now to those add-ins? Maybe you can elaborate a bit on those.
Yeah, don't know if you're that familiar with Calibri. Calibri is a tool which calibrates the parameter, actually more or less the parameter in front of the travel time. So that means the utility function is composed by many components, and just imagine for now, for simplicity, it is composed only by the travel time, and the travel time has a certain parameter in front of, and then Calibri tries to calibrate this parameter to reflect a certain distribution, trip length distribution. And what we do here is we calibrate the average trip length, so not the shape of the distribution, but the average trip length. And we do it just with another method. We add a certain component to the utility or to the impedance, and the other way Calibri changes this given parameter. So I would say it's a different approach. Calibri is not that, or it does not find that precise a good parameter, or say if you want to have the average trip distance fulfilled, then you need this new add-in, which produces very good results, or results which are very close to that what is desired.
So actually, with these new add-ins, you suggest rather using these new add-ins and don't use Calibri? Are there any cases where it makes sense?
It is also a question of taste. So I personally would use only the new one, because if you change this parameter of the travel time, you also change the reactivity, the elasticity of the model. If this is wished, then you can do that and you can use Calibri. But if you actually don't, if you actually want only to calibrate the trip length or the average trip length and not the elasticities of the model, anyway you should use the new one. So it is not that invasive. It changes only that what you want.
Okay. We have quite a few questions from the audience. One is, model choice calibration only change the model constant. Can we also calibrate the weights of the attributes that intervene in the impedance?
Yeah, that is what I said before. I mean, Calibri does it in a way, but not individual for each of these weights. So and not that perfect as you would expect. So actually, also in that case, I wouldn't say that Calibri is would be the right choice. Calibri is more for a first guess, but this what you I think have in mind is not done by none of these two add-ins.
Okay. Then quite a few questions hit in the direction of if this way can be used also with VSAM and EFA, or is there any issues?
So VSAM is possible. So this I forgot to tell that. This Auto-Calibration add-in works for 4-step models and VSAM models currently, and also only if you use the logit function. The reason is just that it is a lot of, it is a starting point. We started with this solution, and if there is interest, we can also extend it. but currently it works only for VSAM and 4-step model, and it can be okay. It could be extended possibly, but if it works with VSEFA, I'm not sure, because VSEFA has already mode split calibration in it, so it is inherent in EFA. So actually,
Okay.
it does not make sense another calibration part.
Okay, thanks a lot for this. And what is a general benchmark for the tolerance error between a model and reality situation?
The benchmark, I mean, that's what the customer wants. Actually, I know some benchmarks for count values, but for the demand, I don't know. So it depends on, first, of course, of the data, if there exists some data to be compared. But I mean, if you use such a tool as explained here, then you can reach any benchmark, and it does not mean that you change the model that much. If you are quite near to the desired values, then you even need only to change the constants only a bit to get even nearer to the desired numbers. So actually, there's no need anymore to be, say, 1% away from the desired values, because it's so easy to come directly to that what you want.
Okay, thanks a lot for this. And I think this add-in is standard in Visum 2021, or does the user have to do anything special in the installation?
Just as far as I know, not. No.
Okay, so it's standard. Then another question about if it works on VSAM. You said it works with the log sums, but also with the destination choice, or just with
it log sums?
Oh, no, you said it works with VSAM, and then does it work with log sums for destination choice as well?
Yeah. I mean the concept is the same. This log sum gets, I mean, the log sum is only a part of the utility function of the destination choice, and then we just add this term beta times direct distance matrix, and it works as well. So there's no difference.
Okay, the next one. I just read it out. I don't understand completely what he means. When does the demand modeling stop? Is there a fixed number of steps or some confidence interval around the percentage of the model split?
No, in the current, I mean, the current implementation produces this loop procedure, this go-to procedure. And in the default, the go-to procedure is just, I think there is 5 iterations. That's a default value. So if you use just the default, then you would get 5 iterations, and that's it. Of course, you can implement by yourself a certain criterion, and then add it to this go-to procedure as a criterion to stop or to go further. So that's actually quite open. It is only a first default setting, and then you can change it. So, and there's no predefined such a significance value or so, but you can do that by your own.
Okay, thanks a lot. Then the next one, is the average trip length somehow weighted with the demand?
Yeah, the average trip length means somehow the average over all trips, or of course weighted by the demand, the average of all trips, the average length of all trips. So that is automatically, I think, weighted with the demand. That's the meaning of it.
Yeah. Then also tipping on this point of Calibri again, would it be an approach to use Calibri to get the good trip length distribution and then the auto-calibration process?
Yeah, actually, I'm not that familiar with Calibri because on the one hand, Calibri tries to adapt the choice model to a certain trip length distribution. But on the other side, there's only 1 or 2 parameters to do that. So that means, for example, if you use a logit model, there's only 1 parameter. And you can imagine that 1 parameter cannot change the shape of a distribution, not that much. There's only 1 to change, and that means actually even Calibri does not adapt the the destination choice to a certain distribution, but it makes it only maybe the difference between desired and model shape is then minimal, but it is not really a shape calibration. So actually, yeah, I forgot the question, but if Calibri is for
Calibri
the
first and then auto-calibration.
No, I think Calibri is good to get an idea, a first estimate for this, for the parameters in front of the travel time. For example, if you use the travel time or whatever you have as utility function, and then the Calibri estimates this general factor in front of the whole utility function. And for that, it is okay. But you won't be satisfied with the trip length distribution, what comes out of it. It is not, it could also be far away from that, what has been observed, what is the target. And that means also in that case, you would need to calibrate again the average trip length.
Okay.
So it would be a combination maybe.
Yeah, because it's one question goes in the same direction. If you start the calibration, you could use Calibri first, and then as a second step, the new calibration process.
Yes, I would say in that way. Or you, yeah, and Calibri is not always necessary. You can also use, for example, old parameters from other models where you already know that they work quite good or so. So it is not always necessary to calibrate new parameters, I would say.
Okay. Now, one of the participants suggests to calibrate the weights of a model, use Biogen at best. Maybe you can elaborate a bit on what you can do with Biogen and what you can do with our auto-calibration process. That probably not everyone is a hardcore demand modeler, and maybe you can put everything a bit in a perspective here. This would be great.
So Biogen would be the perfect choice. Biogen is just a software, and you can estimate parameters of a discrete choice model based on data, of course. And that is typically the crucial point. You don't have the data, what you need, because actually for Biogen, for a parameter estimation, you need stated preference results. So you actually have to do a stated preference survey, and from these results you can estimate the parameters of a choice model. And for that you would use then Biogen as a software in the background. And this would be perfect. And then you would have the parameters, but not the constant. Such a model can never estimate the constants. So that means in a perfect world, you would start with the survey, with a Biogen estimation. Then you have all these weighting factors in front of the single aspects of a utility function. And then you would run this new calibration add-in, which delivers then the constants. Because these constants is never such a parameter estimation with Biogen can never deliver the correct constants. So that would be perfect. And then you would even not need to use Calibri, of course.
Okay, well, we even have more questions. So, and the good thing is we even have also still some time. So please continue with your questions. So the next one, does average distance calibration change overall trip distance distribution? initial shape of trip length distribution? Do you understand what's meant here?
If the calibration, so the calibration of course changes the average trip distance. Which one is it?
This one. Does average distance calibration change overall trip distance distribution?
So the trip distance distribution is of course changed somehow, of course. I mean, if you, for example, your model reflects or the average trip length is too long in your model, then you would shorten it, you would give some impedance to long trips. And then, of course, the distribution changes as well. I mean, then the longer trips occur less often. That's the reason why you do that. The shape could, of course, slightly differ. I mean, just because you have a new situation and then also the shape may change, but it is not intended. I mean, the calibration procedure does not change actively the shape. It only changes the average trip length in the sense that longer trips are more punished than shorter trips. That's actually the only idea.
Okay, thanks a lot. Then the next one is the average trip length that the add-in compares to also based on DID?
That is not necessary. So you can choose. Actually, I did not show that.
What is DID?
DID is the direct distance matrix. And I explained, so I did not want to confuse you too much. So I did not turn to this point. In the first step, in the preparation add-in, you define the effect, the calibration effect. That means so there you use the DID, the direct distance, because you want that this additional term does not change the elasticities of the model. So you add beta times DID, beta times direct distance. But later then, in the execution add-in, you can define different metrics. So for example, a travel distance matrix, because typically your target values are travel distance and not direct distance. So what comes out, for example, from surveys, from mobility surveys or so on, then you typically have the travel distance, and that is then could then be used to compare target and actual values. So that is possible.
Okay, thanks a lot. And now here comes a suggestion. After you have explained what Biogen can do, have we ever thought about adding this as a new add-in? Maybe it's a different product, so we can't directly put it as an add-in, or what is the best way to use Biogen working with Visum?
Yeah, we have thought about it. We have it even on our list to do that, and it is quite comfortable to do that because Biogen is already a Python package. So it should be theoretically possible, and it shouldn't be that difficult to do that, so that you somehow connect Biogen with Visum. The main problem is that you still don't have the data. I mean, for some persons, this might help, but those who would use such a new feature or such a combination, first it is, I would say, a quite small set of people, and on the other side, it is not the most complicated part or the most costly part of parameter estimation to combine Visum with Biogen. And if you don't combine it as the questioner here requests or asks for, then you have one step more to do to put the data out from Visum into Biogen, and that doesn't work automatically. But all the rest still remains. And the far biggest part of that is doing the survey. And since a survey costs about a few €100,000, this is the barrier, and not the connection between Visum and Biogen. So the answer is, it is actually a good idea. It is not that difficult to do, but the win is not that big that we thought it should be done. So if we get more and more of such requests, we may overthink that, and maybe we do that we will implement that, but currently we don't think that it is so important. There are other things which
okay.
are more important.
More questions coming in. So what is the better one? Should we use this auto-calibration process or a manual calibration process? Maybe you can show a bit what are the when should you go manual calibration, or where are the real benefits of the auto-calibration process?
Yeah, it depends on what you would do manually. So of course, just I highlighted that in the beginning a bit, but first I want to say it is always necessary before you start such a calibration to look or to search for errors in the model, or if the model is not appropriate for the situation, if it is not enough segmented or so on, and that there is a need to extend the model. That is the very first, or say the first, second, and third point. And only if there's no way, if you don't find any reason for the differences between model and reality, only at that point, so somehow when you are already completely disappointed and you don't know how far, then you use this approach. And if you use this approach, so just add a constant, and you don't know why actually, only to force the model to reflect reality. If you do such a step, then it doesn't make any sense to do it manually instead of automatically, because you do absolutely the same, maybe not that fast, not that efficient, but there's no difference because you don't put into it some intelligence, I would say. So that's actually my experience. We did it in this way. We add or we change the constants as long as there is a difference between desired and model values. And so I don't see any problem to use that. But what is always important, when you finished, then the manual work again starts, and that is checking the betas if they are not too big. If you do not, I mean, that is a good hint. If you result in a beta of, say, an impedance like 20 minutes, then there seems to be something wrong in the model. I mean, if you did not model an effect or an aspect which has an effect of 20 minutes advantage or disadvantage, that's a lot. And then you can go back to the model and say something is wrong here. I need to extend the model. So the manual work to check the betas, that must always be done. But otherwise, there's no need to calibrate manually.
I think the very important point is you always need to have a very skilled modeler to calibrate a demand model. And it's not saying now we have an auto calibration process. Now anyone can calibrate a demand model. Just press the button and then the model is calibrated.
Exactly.
I think that's a danger. Maybe we should say
that is a danger, and that is the reason why we have this tool so late, because we see always this danger that exactly this happens. And that should never happen, because that's not only bad for your model, but also that models in general are not seen as very reliable if they are used in this way.
Yeah. Okay. Basically, if you can work with Visum, doesn't mean that you can calibrate a demand model. It's a special skill which you have to learn. And I think we have a course for demand models. It's 3 days at least, and then you need to build your experience. And I would say these auto calibration tools are tools to help you and to make these processes faster and quicker. Now we come to another one. You mentioned that the EFA distribution mode choice step somehow represents what we see in this auto calibration method. What is the main difference then?
It's just another approach. I mean, EFA has another distribution methodology. A typical 4-step model uses, for example, the logit model. It's just another concept, and EFA has a so-called 3 linear equation systems, something like that, and with some how they called, with some constraints. And one of these constraints is the mode share. And then the system solves a system of equations, a linear equation system with these constraints. And so it is automatically fulfilled, the constraint of the mode share. So if you just want to know what is better, I cannot say. It is, in both cases, it is somehow a blind correction, a correction without any reason behind. So there's no real aspect of real world behind why a certain correction factor is given there. So in both cases, it is in some way stupid machine which adds some correction factor to it just to result in the correct values. So there's no qualitative difference between EFA and this kind of calibration.
Okay, now we really have to look for time. Now, one final question. Does this auto-calibration works for demand model in case of mixed traffic situations, such as no lane behavior? That's more represented by the assignment model,
or which behavior?
No lane behavior.
What does it mean, no lane behavior?
I think that people don't stay in lanes. That basically you have a 3-lane road, and then in mixed traffic conditions you have four cars in 3 lanes. But this is something which is represented by an assignment model.
Yeah.
And therefore, yes, it can be used. I think the important thing is how it's represented in an assignment model if you have this no lane behavior.
Yeah, I'm sorry, I'm still confused about no lane behavior. I really don't know what that means.
Okay.
But I think it is really more a part of the assignment
model. Okay, maybe you can take this question then to the Visum chat room, where we have then also our assignment experts there, and then you can elaborate on this. Well, thanks a lot, Martin, for your presentation and answering all these questions so well. And also, well, thanks to all the participants. We have again a record in participants. Now we have almost 140 participants, and also thank you very much for all your questions.